Okay. Done? Okay, my dear students, welcome to the Made Easy Temple of Learning. My name is Swamy Gupta. So let us discuss now the structural analysis part of our CAT. So first question we have taken on the trusses. We want to find force in the member LM. Allotted time is 2 minutes, means 1 minute we should be able to complete. So what is our line of thinking in that? So how many reactions are there, you have to see first. There are 4 reactions. If you take the reactions, 4 reactions are there, because there are 2 hinge supports are there, VA, HA, VB, HB. So before we want to find force in member LM, you must first find the reactions. There are 4 reactions. We have only 3 equations of equilibrium. So one reaction extra is there, which means that you have to use method of sections once to find the support reactions. So number of this is our line of thinking. Number of reactions are 4, equations of equilibrium are 3. Since there is one extra reaction, we have to use this is first line of thinking. We must use one method of sections. Once you have to use the method of sections, right? Otherwise you cannot find the 4 reactions. That is our first line of thinking. Since the means I am giving you how you have to think, the process of thinking, allotted time is only 1 minute. So 60, loading is symmetrical. So since vertical loads are symmetrical, both reactions must be equal. VA must be 60, VB also must be 60. Since HA and HB, though there is no horizontal action, reactions will develop because there are 2 reactions. If at all here roller is there, then both reactions will be 0. But since 2 reactions are there, we cannot say that they are 0. Fine. So HA and HB will not be 0. So we have only 3 equations of equilibrium, 4 reactions are there. So one extra reaction is there. You have to use method of sections to find the reactions. Then how to use the method of sections to find the reaction? You must cut the trusses such that the unwanted members other than the reactions should meet at one point. Supposing that if you decide to cut it, say like this, by 1, 1. What is the rule for that is, these 2 member forces as of now we don't want when you are finding the reactions. So unwanted members are meeting at L. So take moments of all forces about L is equal to 0. Then you can find HB. So that is your first process. From equilibrium of, from RHS of 1, 1. So take moments of all forces about L. Sigma ML is equal to 0. So minus 60 into, see 6 panels are there at 4 meters, 4 plus 4, 8 plus 4, 12. So minus 60 into 12 plus HB into 6 clockwise. This is also clockwise, plus 60 into 4 So from this you will get what is HB. 60 into 12, 16 4 means 60 into 8 by 6. You can write like that. So HB you will get 80 kilonewton. Supposing that if you get a doubt how it has come, HB is equal to 60 into 12 minus 60 into 4 by 6. Common is 60, 12 minus 4 is 8, so 60 into 8 by 6. That's how that 60 into 8 by 6 we have written. So this is our first task, finding the support reactions. Because one extra reaction is there, one method of sections we have used. So for that equilibrium of RHS of 1, 1 we have taken. So 80 kilonewton is HB. Now we want to find force in the member LM. So cut here, look right side. Now if I want to directly find LM, FL also is there. FL also will have X component. So can we find somehow force in the member FL? Cut here, look right side. See, panel shear force we call it. Panel shear force means unbalanced vertical force acting on the right hand side of 1, 1. 60 down, 60 up. Right? So net vertical force is already 0. So from that condition, this will not have Y component. Only this should give Y component, so it should be 0. Y plus 60 minus 60. So sigma Y is already 0. This doesn't have any Y component. So only this, it has to be 0. Right. So this is 0. Now finish. Now stand here, look right side. 80 left side. To balance it, it should be 80 right side. So force in the member LM. $80 kilonewton compression. So our 1 minute time exhausted. This is only story, line of thinking. How many reactions are there? You will see first 4 reactions. That means in excess of equations of equilibrium, one reaction extra is there. So once you have to use the method of section to find all the reactions. So find the reaction, then force in member LM we want, cut it, look right side. So for that this also has come into picture unnecessarily. So can we find this one? We can find this one by taking sigma y0. Stand here, look right side. Sigma y0 when you write 60 down, 60 up. That means panel shear force in this panel is 0. If panel shear force is 0, force in the inclined member in that panel is always 0. So 0 put it, then you will write sigma x0. 80 left, 80 right. 1 minute over. So this is the scope, force in the member LM. Right. Now let us see the next question. I think this is how we will manage how much time we have to take, only that we will see what is the panel shear force, etc. I am assuming that you have known them. Let us see the second one. Force in the member BC we want to find. The first task is how many reactions are there. A similar example is this one. Now here VA, HA, VE, VD. Now since again 1, 2, 3, 4 reactions are there, you have to use one method of sections to find the all support reactions. Some reactions may be 0, but still we have to use method of sections. In this structure there is no horizontal force, no horizontal action, only all are rollers, only one reaction was there, so HA should be 0. Over. Now to find other reactions you must use method of sections. So we will cut it by 1 1 like this. Cut it by 1 1. Now look left side. Stability and all, don't worry now. Since if they ask you force in the member BC, it means that it should take only 1 minute time, and also it means that it is a stable truss and also statically determinate. Otherwise you can't find in 1 minute time. So cut, look left. See here, these two forces will not give any vertical component. So 100 down. To balance it, VA must be 100 up. So only on the LHS we are seeing 100 down, 100 up. So sigma by 0 satisfied. Now see right side. If these two forces are giving a clockwise couple, this should give anti-clockwise couple. So that means two reactions only should resist this one. So VE cannot act upward because this is already clockwise, it should be anti-clockwise. So VE must be downward. How much? Distances are same. So VE must be 100 kilonewton down, VD must be 100 kilonewton up. So that is, say you have taken 20 seconds time. Cut. First HA0, 100 down, 100 up, forming a couple, anti-clockwise couple. Let us assume that 20 seconds are exhausted by that. Now coming to this one, we want to find force in the member BC. Which equation of equilibrium is better to find force in the member BC? We are not interested in force in the member EF, right? So EF member, since we are not interested, take moments of all force about F equated to 0. Sigma MF0 if I take it. So from FBC if you want to find, from we are considering equilibrium of LHS of 1 1. Only LHS of 1 1 we are taking. Take moments of all forces about F is equal to 0. Why F? Because I am not interested in finding the force in the member EF. So that will not give any headache. So it will give 0 moment. So some force you can assume here FFE, let us say. So this will give 0 moment. 100 will give 0 moment. So most two forces will give 0 moment. We didn't cut them, so their headache is not there. Now when I cut and look left side, HA is already 0. 100 is giving about F clockwise moment. Tail to the head towards F plus 100 into 4 clockwise. To balance a clockwise movement, there should be anti-clockwise. See how our fingers must move like this. So anti-clockwise. Then question of negative sign will not be there. LHS of 1 1. You are taking moments of all forces about F is equal to 0. So this is equation. This is not bending moment equation, this is equilibrium equation. Equilibrium equations means it deals with only external effects of the forces. Means whether it is in equilibrium or not. If not in equilibrium, with what acceleration it translates or rotates. Internal bending moment equation means what that movement is doing. Is it bending or twisting? When you are writing bending moment equation, you are writing internal effects of the movement. Right? So plus 100 into 4 minus FBC into 3. So FBC you will get 400 by 3. So one of the option will be 133.33 kilonewton. Like this. Supposing that if at all you are asked to find force in the member EF, let us say, Then after finding this one, I can find sigma x is equal to 0, FFE will be from sigma x is equal to 0, this is again LHS of 1 1, FFE must be equal to 133.33. Arrow mark away from the pin, so tension. Once you assume this correct, one left side, this has to be right side. Right? 133 point. Aman Agarwal. Oh my goodness, good. Video is still lagging. Yeah, we'll check that out. So many are answering correct. Right. Now 133.33 kilonewton. This is how, whether they ask this one or this is same. If they ask you force in the member CE, suppose, we don't know which question they will ask. Force in the member C, if you want, say, this is 100 down, this means it should be 100 up. Away from the pin, away from the pin. So you will get 100 kilonewton away from the pin means tension. So like this, either they can ask you what is the force in member BC or CE, FE or CE. But first task is count how many reactions are there. Based on that, how many equations of, how many methods of sections, how many cut sections we have to use, you should decide. Okay. Now let us see this one. Force in the member CL we want. That's what is the question. Allotted time 1 minute. First check how many reactions are there. How many reactions are there in this truss? There is a support here, VA, HA, here, VC, HC, then here, HM. So 1, 2, 3, 4, 5 reactions are there, but we have only equations of equilibrium 3. So we have to use 2 times method of sections to find all the reactions. This is first thinking. Support reactions are 5. That means 2 reactions extra. Then 3 equilibrium equations. 2 reactions extra are more than 3 equilibrium equations. So use method of sections 2 times. To find all reactions. After finding the reactions, I can find force in the member CL. Okay. Now come to this one. VAHA. You must, as first problem I told you, to find the reactions, you must cut the member such that they should not come into picture at all. So if I cut the truss like this by a section 1 1 like this, say, only once not enough, one more is required, we will see that. Now from LHS of 1 1, If I take it VA into 2, take moments of all forces about F is equal to 0, plus VA into 2 minus HA into 2. From this you will get VA is equal to HA. But I told you the one is not enough, 2 are required. Let us see on the right side. We will cut here. We will get one more condition. Let us take this as a 2, 2. From RHS of 2, 2 can we find anything? You see, you are cutting the members such that these two members will give 0 moment about L. So these two headache will not be there. Only reactions will come into picture. So like that. So second one, from RHS of 2, 2. If I take which equation of equilibrium is better, so that most of the unknowns will get lost. HM is passing through L, VC is passing through L. They give 0 moment about L, our headache is gone. So HC into 2E will get. Take moments of all forces about L is equal to 0. So you will get minus HC into 2. You will get HC is equal to 0. So 2 equations we got from this one. But HC is equal to 0, HA is equal to 30 we cannot tell, because HM also is there. Now we will take this only method of sections. You have taken 2 extra equations, we got it. Now we will use equations of equilibrium. Take moments of all forces about, say, E is equal to 0, sigma ME is equal to 0. Then what is the advantage for us is HM is passing through E, VA is passing through E, so they will give 0 moment. You are not taking any method of sections, from equilibrium of entire structure. So if I take that, you will get like this. From equilibrium of entire structure, you must select a moment center such that most of the unknowns should not come into picture. HM, VA, for them not to come into picture, sigma ME is better. Take moments of all forces about E is equal to 0. So 30 gives 0 moment, HM will give 0 moment, VA will give 0 moment, this minus HA into 2. Minus HA into 2 plus 30 into 2, 3, 4, 5 plus 30 into 5. Next, HC anyhow we found 0, HM is 0, minus VC into 2, 3, 4, 5, 6. Now HA we already found that it is VA. HA is nothing but VA itself. Now we can get from this one so 2VA minus 6VC minus 150. In other words, we can write VA plus 3VC is equal to 75. Next, again from equilibrium of entire structure, I can write sigma y is equal to 0 plus VA plus VC minus 30 is equal to 0. So from this we can get VA plus VC is equal to 30. So if I take from this one, cancels, this is VA. VA plus VC. So subtract them, minus, minus, minus. So you will get 2VC is equal to 45. So VC you will get 22.5 kilonewton. If VC is 22.5, force in the member, CL we want to find. If this is upward 22.5, this has to be downward. Same towards the pin, towards the pin. So force in the member CL you will get So this is the process. First we will see how many reactions are there in excess of equilibrium equations. So many times we have to use method of sections to find the reactions. Then whatever force he is asking we can find. Yeah, it is 22.5. So this is the process. Now we want to find how many members have zero force. Number of members with zero force. Can we detect how many members have zero force? So come to say first from here. 1, 2, 3. 2 are in line. Third must be 0. Over. Come here. B. This is one way of detecting whether member force is 0 or not. If 3 members or 3 forces are meeting, 2 forces or members are in line, force in the third member is 0. One thing. Next come here. 2 non-collinear members, no external load, so forces in both members are 0. Okay. Now coming to this one. At I, 2 non-collinear members, no external load, so forces in both members are 0. Next come here. 1, 2, 3, 2 are in line, third must be 0. Once this is 0, these two non-collinear members, no external load, these two forces also must be 0. So number of members having 0 force are 8. That way also they can ask. Number of members having 0 force. 8 members. Okay. Let us now, if we take this one, we have calculated force in the member BC, force in the member FE, right? Now if you want to find force in the member BF, let us say, that also can be a question after finding this one, then you must cut it. Force in the member BF means you have to cut it such that the unwanted members should meet at one point. I am taking one more question here. We want to find force in the member BF. For that, what we can do is we can cut it, say like this. This is, you can say 2 will take it. So we are cutting here looking above. This member we are not interested, this member we are not, this didn't cut at all. This we have found it as 133. So after finding this only we can come to this one. Then if you want to find force in the member PF, cut here, look left side. Next, this is 100 is giving clockwise movement. This 100 is giving, if I take moments of all forces about A is equal to 0, let us say we are taking about A. So this will give 0 moment about A. FBC will give FBC into 4. This is anti-clockwise. Now this should give clockwise moment about A. Like this. FBF. Anti-clockwise, clockwise about A. We can find what is FBF. So to find FBF, take sigma MA is equal to 0. Cut it by 2. You will take equilibrium of LHS of 2. Then sigma MA is equal to 0. Sigma MA is equal to 0. So minus FBC into 4. Then plus FBF into 4. FBC got 133.33, which means that FBF you will get now what will happen to this one? It is arrow mark is away from the pin, so tension. So this is one way of asking another question. Let us see this question also. How many members have 0 force? Suppose if they ask like that, number of members having 0 force. How we will detect? This already you found 0, so this is also 0. All the top chord members are under compression. So now see this one, 1, 2, 3, 2 are in line, third must be 0. Now once this is 0, see this joint E, 2 non-collinear members, no external load, that means these two also 0, right? Next, coming to this one, 1, 2, 3, 2 are in line, third must be 0. Right. This is upwards or downward, this should be there. This will, members will, forces will develop. Then what else we can tell? This is 0 already. Coming to this one, 1, 2, 3, 2 are in line, third must be 0. So mirror reflection on the other side. So if this has to be 0, this and this will be 0, this is 0, this is 0. That's all. Then 1, 2, 3, so this also should be 0. This 60 must be resisted by this one. We cannot say that it is 0. One, two, three, 4 are there, so we cannot say that. Three, 6, 5, fine. So is the case here. We cannot say that this is 0. Like this. So total forces are, you will get 5, 10. 10 members have 0 force. Slightly I shift it up. So this how you will find. We don't know which process they will ask you. Ten members have 0 force. KD will not be 0, correct. So that's why 10 members have 0 force. So on this one discussion is complete. Either they can ask you what are the members which have 0 force, slightly difficult then for that question, because first you have to detect these two are 0. Means after detecting them they are 0, this is how these things will come. Okay, this is also we have completed. This all discussions we have made. Right. Now let us see that's about the method of sections, method of joints. How to detect whether member forces are 0 or not. Then if at all more reactions are there, you have to use method of sections. Fine. So whatever may be the question they give us, it will fit into this process of thinking. Now let us see displacements in the trusses. For the truss shown in figure, member BD is subjected to a temperature rise of 30 degrees centigrade. Relative displacement of joints B and D in the direction of BD. So once they give you like this, first read the question. Allotted time is, first we should be time conscious in this one, 1 minute time. Even in gate also you will get maybe 1/2 minute extra, you may get it, that's all. So within that stipulated time we should be able to manage. Okay, so relative displacement, C 1.8 mm, yes, correct. (1.8 mm). So within that stipulated time we could manage. See here, member BD is subjected to temperature rise 30 degrees centigrade. Relative displacement of B and D. Once there is a member at the joints B and D, whatever temperature change is there in the member BD due to temperature rise alpha TL, so that joints B and D should move either away from each other or towards each other by the same amount alpha TL. So relative displacement, if member is not there, then to find the relative displacement you have to use sigma P KL by AE or K into delta. But if since those questions have already given, this is another way of asking the questions. So relative displacement, so expansion delta BD is equal to alpha TL. Alpha is 12 into 10 to the power of minus 6. Temperature rise is 30 degrees centigrade. Length is, this is 3, this is 4. Then what is the length of this member? Five meters. Five meters means I will write here 5000 mm. So whatever amount BD expands, relative displacement of joints B and D will be same. Okay, if member BD is not there, then what to do? If member BD is not there, then delta BD you have to calculate summation of K into delta. This is usual process. This we know how to do that, sigma P KL by AE or sigma K into delta. But if they want to save your time, they give you member and relative displacement if they ask. 10 seconds you can complete the solution. Okay, this may be full 1 minute to 1.5 minutes you have to spend. But if member is there, if they ask you relative displacement, if member is there, if they ask relative displacement, then alpha TL itself will become the relative displacement of the two joints. Okay, so that's how we should manage the solutions. How to get out in 30 seconds to 1 minute time, we are trying to check. Now let us see next one. For the truss shown in figure, again on the deflections I am giving, allotted time is only 1 minute to 1.5 minute time. So to read the question, understand it, assume that you have taken 30 seconds time, then to solve it 1 minute you should finish off. So for the truss shown in figure, if compression members are stressed to 100 MPa and tension members are stressed to 120 MPa, relative displacement of joints A and D. Again question is, relative displacement of joints A and D in the direction of AD. In the direction of AD, if members are not there, again sigma P KL by AE. But if members are there, whatever individual displacements are there, those individual displacements or individual elongations or contractions, you simply sum them. That will become relative displacement itself. 30 seconds you can complete. See here. Again, another point you have to remember is, this is a simply supported truss. In a simply supported truss, subjected to downward loading, top chord members are under compression, bottom members are under tension. That's what we have learnt. So all top members are under compression. So this is our line of thinking. What are the members subjected to compression? Right? So all top members are under compression. Stress is 100 MPa. These members may be subjected to compression, may be subjected to tension. We are not interested, because members here, consecutive members are there. Individual contractions of the members, if you add them, how much joints A and D moved inwards, we will get it directly. Right? What is the relative displacement now? Relative displacement of joints A and D. Sum of the values FL by E. PL by AE for AB, PL by AE for BC, PL by AE for member CD. But P by A values he has directly given. So now I am writing here. PL by AE means I can write FL by E into 3 directly I will write, because 3 members have same thing. 3 because 3 members. This story is for the people who are listening first time, but otherwise FL by E into 3 directly we can write it. This explanation you don't have to give to anyone in the exam. So stress is 100, length is 4 meters, Young's modulus 200 GPa, like that 3 are there. So this value you will get. Yes, my goodness. So I think all of you are thoroughly, completely understanding what we are talking. You will get around 6 mm. So 6 mm is the option. Your 1 minute time finished. It's like that. So in 2 minutes time our task is this much. First you have to understand what is the meaning of relative displacement and which topic it belongs to, and allotted time is 1 to 1.5 minute time. With these constraints, you must think like this. In the first forces in the members of the trusses means you must first count how many reactions are there, then how many are there more than 3, so many times method of sections. Then question becomes simple. In deflections, displacement, they will ask you relative displacement. If members are given, continuous members are there, individual deformations you add them, either due to temperature change or due to the applied loads. Some load WW given, top chord members are under compression, so individual contractions will give you the relative displacement of two joints. Now let us see again, one rotation we take it, rotation of the member AB. Yes. Now what is the rotation of the member AB? Again 1 minute time. Within the brackets whatever we have given, they are plus means elongation, minus means contraction. Rotation of the member AB. This is a truss. Positive sign indicates elongation. Member AB elongated, member BC contracted, this also contracted, this is elongating. Due to what? We are not interested why they are elongating or contracting. This elongation may be due to some fabrication error. 4 mm extra he has cut, this is 5 mm short they might have cut, 2 mm extra they have cut, like this. So these are maybe due to temperature change deformations, or due to fabrication errors, or due to loads. The reason for those deformations not given, neither we are interested about it. Now rotation of the member AB. If the displacements perpendicular to the member are known to us, we don't have to use, actual formula is theta AB. Formula is same, PKL by AE is nothing but summation of K delta. This we use it if we displacements perpendicular to the member are not known. Now perpendicular to the member AB, displacements are known to us. How much is the displacement of A, left or right? 0. Displacement of B. See, stand here and look at B. 5 mm contraction means it goes right side. So if you draw the deflection profile of that, it will go like this. This is the member, initial position. This is A, this is B. So stand at C, look at B. B is going left side. So put it that 5 mm left side. This cannot move, only this moves. B will go to B dash. This length is 5 mm. AB length is 4 mm. 4 meters means 4000 mm. Theta AB. So what is theta? Theta for the member AB. See, it is rotating clockwise. Opposite side by adjacent side. If they ask specifically, means slightly extra also they can ask you, 1.25 10 to the power of minus 3 radians clockwise. That also they can ask. Yes. Mithali Chavan, Naidu, Prudhvi Jadhav, Aman Agrawal. So I think most of you are understanding what we are talking. I think your thorough revision was there. So this is how the rotation of the member AB is formed. Within say 20-30 seconds time, if invigilators are pulling the paper and manage the means, this will manage and get out. Right? Next. Okay. Now for this, what is the answer? This we'll discuss about this one. We want to find, first of all, assume that you have only 20 seconds time. We'll see how to manage in 20 seconds time, then complete discussion will make it. ILD for force in the member L3, L4. L3, L4 is in a simply supported truss. This is bottom chord members. Bottom chord members are always under tension for all positions of the loads. Now, this they have given tension. This is compression, tension, tension. So, compression means negative indicates compression. Positive sign indicates tension. Now, second one ruled out. It cannot be compression. Okay. Now, when you cut them, L3, L4 you are cutting. So L3, L4 is our point of interest. You cut it like this. So what are the points that we have learnt is, bottom chord members for all positions of moving loads, it should be under tension. So from that logic B you have removed. A, let us see why A is not correct. Between the panels, L1, L2 is one panel, L2, L3 one panel, L3, L4, L4, L5 one panel. Within the panels, ILD must be straight line, right? So it cannot be two bilinear curves will not be there. Single way only, it should be very linearly. This is tension only, but see here, first panel L1, L2 straight line, fine, L2, L3 straight line, L3, L4, this is one panel, but you see how it is going? It's going up like this, it's going. Within the panel it should be single straight line, so this is wrong. Now this is also plus was there. When I am cutting it, L3, L4, unwanted members are meeting at U3. But if I take this one, L3, L4, two lines were there, so it is wrong. If I take this one, everywhere tension only was there, means tension is there, single straight line, single straight line, single straight line, single straight line. We will take this one. Now, if I cut here L3, L4, apex cannot be at L3. This apex we have written, unwanted members are meeting at U3. Means when I cut here, these are meeting at U3. But apex was at L3. That means this is also wrong. So only choice left out is C. What are the rules to be followed? Bottom members always under tension. They cannot be, compression to tension will not be there. Within the panel it must be single straight line. Next, when you cut the members, when you cut this one, where the unwanted members are meeting, you have to see. Unwanted members wherever they are meeting, at that point only apex of the triangle should be there. So if at all I extend this line, apex of the triangle will be somewhere here. But within the panel it must be single straight line. So it cannot go up and down like this, it should go this way. These are the rules. Within the panel, single straight line. Then unwanted members wherever they are meeting, at that point apex of the triangle must be there. So from that point of view, we could remove this and this, because within the panel two straight lines are coming. So only choice left out is C. That's the line of thinking. Next. Good. Now see this one. How we have to manage. 1 minute time. What is the answer? BCEF. BC and EF, correct? BC and EF is correct. Ankan Pramanik means B is the correct option. Okay, then how to manage? As we have explained, allotted time is only 1 minute. Again, any question in structural analysis that they give will never take more than 1 minute time. Even if you make mistake, correct it, even in spite of all that, 1 minute you can. See, I told you, if at all at any intermediate support of a continuous beam, if you want to draw ILD for bending moment, ILD will decide. So first you have to assume an imaginary hinge at D. In the adjacent spans, at the intermediate support, adjacent spans, when load is applied, it will always hog. means a negative bending moment will develop. So this is negative bending moment, this is negative bending moment. Once this is fixed, the other part simply have to extend like this, right? This you have to extend like this. Now this is minus, minus, plus, plus, minus. Minus means if you apply loads here and here, you will get negative bending moment at D. If you apply load here and here, you will get positive bending moment at D. But we want maximum sagging bending moment for that one. So first we will draw ILD for bending moment at D. First assume a hinge, adjacent spans negative bending moment, negative area, then extend the lines. Then that ILD will tell us which spans we have to load them. So leave these two spans, load only these two. You will get maximum sagging bending moment BC and EF. BC and EF. So this is to get maximum sagging bending moment at D. If at all they ask you to get maximum hogging bending moment at D, what is the condition? You must load adjacent spans and alternate spans. So you must load AB, CD, DE. AB, CD, DE. If you load these ones, you will get maximum hogging bending moment. This is to get maximum hogging bending moment at D. So question can be hogging bending moment, sagging bending moment. Here I have given sagging, so BCEF. If at all they ask you what is the maximum hogging bending moment, which spans to be loaded, A, B, C, D, D, if you load it, you will get maximum hogging bending moment. So that is about the influence line diagrams. Likelihood questions we are talking, so that with these questions we should be able to recollect entire chapters, whatever we have discussed. Next, we want to find delta deflections of the statically determinate frames. Only determinate we are discussing. Cantilever means fixed support, free end. So it is a determinate frame. So you must use only strain energy method. Then they will give you only two spans. So two segments only given. So 1 minute we can complete. So your task in 1 minute time is this one. Delta HC, integral of mx m dx by ei. In the exam, in the rough work, you don't have to explain what is mx, what is m, that headache we are assuming that we have known. So we will take up mx and m diagrams. Here itself we will write. This much is sufficient. Because now we are checking the time also, 1 minute time we are trying. With minimum explanation, we are trying to solve the problem. Because explanations were already, all of you must be knowing. After complete preparation only you are sitting and listening. So now you are only checking the time. 1 minute we are completing or not, we are checking. This is 100 kilonewton. This is mx diagram. This is m diagram. Horizontal displacement we are asking. So you must apply 1 here. It has no units. We will not write now. 2 segments. Cut here, cut here. Cut, cut. This we are measuring from here, x distance. Then stand here. This is stand here only to ensure that you will recollect quickly that chapter. So MX diagram, M diagram. Then we will write the table. Member MX M multiplication. First we will take BC member or CB member, we will write it to avoid confusion. CB member, stand here, look right. Hogging when you went negative, so minus 100 into x. Stand here. Stand here, look right side. 1 will give 0 moment. So that means this is 0. 1 headache is gone. Next, BA member. So stand here, go inside, stand here, look right side. Tail to the head towards dot. 100 into this length is 1 meter. So hogging minus 100 into 1. Next, stand on this dot. Stand here, look right side. Again hogging minus 1 into x. Now I think I can move slightly up. So limits 0 to 4 meters, mx 100, x I means 2i. You must be careful about this I value. So you will get 100, x means x square by 2. So delta HC is 400 by EI. You are getting positive sign. That means right side. So 400 by EI. So D is the answer. So while explaining I am taking more time, but some of you have already calculated. That is the correct way. You check that. First you do it on your own quickly as you can, because some of you are listening first time, means some of you might be absent or some of are not our students. So I need to explain. But most of you have written already that D is the answer. That means we are happy that in the exam also either this type of questions or no question at all, right? So we can easily manage. This is the task. Time 1 minute to 1.5 minute time you can take it. These two diagrams, this one. Issue will be over. Okay, now we'll move on to the next one. Now one cantilever frame we have taken. We'll take one simply supported now. Simply supported, statically determinate frame where the one end hinge, one end is roller, but they are not at the same level. That problem we have taken. So instead of applying a point load at C always, that question all of you know. Now not necessary that they must give load at C only. Suppose a moment is given, say 100 kilonewton meter moment is applied. What is the horizontal displacement of joint C? Okay, so these are the options. 1 minute time, quickly try if you can manage this one. This is our problem. EI flexural rigidity same 10 to the power of 6 kilonewton meter square. So since he is asking you to find delta HC means deflection, statically determinate frame, you must use strain energy method. Only two segments are there. So let us take that. Delta HC means integral of mx into m into dx by EI. So we will take, without drawing mx and m diagrams, don't attempt the question. You may make mistake. So we will write here itself. This is your MX diagram. And you have to apply unit load here. That one has no units. This is small m diagram. Okay. Now how to find the, I am continuously asking you to see that time to ensure that you will manage that, means you will recollect what we have talked. See here, to find the support reactions, I told you that we should not use sigma x0, sigma y0, sigma m0, then find the reactions by inspection. This is clockwise, so to balance it, anti-clockwise. See how my fingers move down, up. How much? M by L, 100 by 5. 100 clockwise, I will write here 100 by 5, 20 kilonewton down, 20 kilonewton up. This no issue. 100 clockwise. So reactions are m by L. 100 by 5. Length, this only have to take it because couple is forming here. 5 meters couple only. So 20 into 5 is 100. Anti-clockwise 100, clockwise 100. Equilibrium. Over. Support reactions are only 2. Horizontal reaction here is 0. HA is 0 because HC is 0. Over. Come to this one. One right side, to balance it here one left side. This length is 10 meters. This is 5 meters. 1 into 10 anti-clockwise, to balance it clockwise. See how my fingers move up, down. 2 up, 2 down. See here, minus 1 into 10 plus 2 into 5 plus 10. Like that. Or m by L we can write it. So 1 into minus 1 into 10 plus VA into 5 is equal to 0. So VA will become 2. So that's how we managed. So now anti-clockwise couple minus 1 into 10, clockwise couple 2 into 5. Equilibrium. Now cut here. Take a section XX, XX, section XX, XX. This is X, X. You can take X here, X here. So MX and M diagrams. Assume that it has taken say 40 seconds time. You are left with 1 minute. In that 1 minute you must fill the table. I move it here. Okay, I lift it up. Member MX, M, how many members you have to write? First let us say CB member. Only 20, otherwise we will write here. For this one, this is for the newcomers, we will stand here. Here also we will stand here. Stand here means stand here, look left. Section XX. Only HA already 0, only 20 is there. Minus 20 into X. Come here, plus 2 into X. First we will take AB member. Minus 20 into X. Because downward, this up, plus 2 into X. So limits of integration are 0 to 5. Minus 40 into x square means x cube by 3. $125, 600. 500. Next, CB member. See here on the CB member, stand on this dot, go inside, stand here, look right side. Point will give zero moment. So once one fellow will give zero moment, other gives a moment or not, doesn't matter. CB member. Mx is 0. Small m plus 1 into x. Limits of integration 0 to 10. Once it is 0, we don't have to write anything. This becomes 0 to save our time. So you will get delta HC. Minus indicates what? Anyone finished by this time? Minus 166. Correct. Most of you finished already. Negative sign means what? Negative sign implies that you thought it is going right side. See here, you thought in the unit load direction is right side, but result came out to be negative. That means our assumed direction for unit load is wrong. Oh, no issue, leftward it acts. So 166.67 by EI leftwards. Since both they have given, this is your answer. Like that. So most of you have already finished. Good. EA is 10 to the power of 6. If you substitute that, you will get kilonewton meter means 10 to the power of 6. So 0.1 mm. We'll substitute that value also. Six zeros means 166 into 10 to the power of minus 3 meters. In other words, 0.166 mm will be the answer. Okay. Next, moment at E is Aviral Chaudhary, not 1666, 166.67. Earlier one. Okay. Now come to this one. Moment at E. So we have a This is in the moment distribution method. So C is a rigid joint, one in fix, hinge, roller, guided roller support, free end. So how much moment is developed at E? So if you draw the deflected profile because of this moment, for this profile we know I by L. This is the deflection profile. This one will take straight line. This also takes straight line. This will go like this. These deflection profiles will decide what should be the relative stiffness of each member. So when far end is fixed, relative stiffness is I by 4. Far end is hinge, 3 by 4, I by L. 3 by 4, I by L. Here to the beam, roller base, beam are parallel. So since reaction is perpendicular, so it will bend like this. In this case, longitudinal axis of the beam, roller base perpendicular to each other. So when I apply a moment, reaction will not come. So it will remain as a straight line. It will not bend. So is the case with this one. It will not bend. Okay, so for these two members, relative stiffness is 0. For this one, 1 by 4 I by L. This is 3 by 4 I by L. So with that understanding, you must write first what is the distribution factor at C for the member CE. That we must know. So we will write that point. Any joint they can ask you. Joint, member, K, sigma K distribution factor. I will show here. Joint, member K, sigma K, and distribution factors are K by sigma K. So you are dealing with joint C. How many members are there? C to A. Far end is fixed, so I by L. Member CA. You have to write I by 4. Next, CB. Far end is hinge, 3 by 4 I by L. CF. CF deflection profile is also same. So it doesn't matter whether you have a hinge support or roller support, deflection profiles are identical. So this also becomes 3I by 16. Next, CF is over. CG. Zero, because it doesn't bend at all, it remains like a free end and this same. Next, CE, 1 by 4 I by L. CE. When far end is guided roller support, 1 by 4 I by L is the relative stiffness. CE is over. Next, CD is again 0. Far end is free. 0. Now to make calculations simple, I by 4 you will write 4i by 16. So 4 plus 3 7 plus 3 10 plus 1 11. 11i by 16. We wanted only CE member. So distribution factor for CE you will get 1 by 11. One by 11. So once the distribution factor is known to us, moment at C, this is our solution. Moment at C for the member CE, distribution factor into M, 1 by 11 into 100, you will get around 9.09. 9.09 means 9.1. 9.1 kilonewton meter clockwise. Moment at C for the member C. What is the moment at E? Is M. How much is the carryover moment? Carryover factor. Carryover factor is minus 1 into 9.1. You will get minus 9.1 kilonewton meter. So you will get moment at E is equal to anti-clockwise, 9.1 kilonewton meter anti-clockwise. B is the answer. Okay. So for this one distribution factor is 1 by 11. So whatever member moment they ask you, we should be able to write that. Fine, we'll move on to the next one now. So, okay, next we'll see. Again, allotted time 1 minute. For the continuous beam shown in figure, moment M required to make slope at D 0. We have a two-span continuous beam, both ends hinge, means the hinge are roller supports. Okay, how much moment M you have to apply so that slope becomes 0? Okay, First again, that means that you must use the MDM. First we will symbolically find the fixed end moments, then release at A and C. Then you will know what is the moment required at B to make the slope 0. Okay. So in this one, first step is finding the fixed end moments. MFAB minus WL by 8. MFAB. MFBA plus 8 kilonewton meters. Similarly, MFBC minus minus 16. These are the moments necessary to make slope 0 at all joints. To make slope at 0 at A, B, C means these are the moments. Next, but we don't want slope to be 0 at A and C. So we release them. So to release them, we must know the distribution factors. So stand at B, look at A. Far end is hinge, I4. Far end is roller, I4. So distribution factors are 0.5, 0.5. So directly we will take up EMD, means end moment distribution. Anyone completed by this time? 8 kilonewton meter anti-clockwise, 12 anti-clockwise, correct. So end moment distribution. EMD means end moment distribution. Joint this is A, B and C. Then distribution factors, if there is only one member meeting at a joint, its distribution factor is 1. B and BC 0.5, 0.5, because two members are flexurally equally strong, I4, I4. So this it is 1. Now you take fixed end moments. Minus 8 plus 8, minus 16 plus 16. What are these moments? If you apply minus 8, theta A becomes 0. If you apply again minus 8, theta B becomes 0. Theta C becomes 0 with that. But we don't want slopes at A and C 0. So release them. Release A and C. Release A and C. Releasing means plus 8 minus 16. When you go and release by applying plus 8, half of the moment is carried over when far end is fixed. So carry over moment. Out of plus 8 it will come plus 4. Out of minus 16 minus 8 will come here. Now we will get net fixed end moments. Here 0. So now that means we are releasing joint A. Here plus 12 minus 24 0. What this net fixed end moments line will tell us, we are not fixing A, not fixing C. We fixed it but we released it. But to make slope 0 at B, this is the moment necessary. Plus 12 minus 24 means if you apply minus 12 kilonewton meter, theta B becomes 0. Then what you have done in regular MDM, because slope is not 0, you distribute this one, EMD, end moment distribution. If you don't distribute, whatever moment you get, that is the moment required to make slope 0. So, moment M required at B, so that is minus 12 kilonewton meter, or in other words 12 kilonewton meter anti-clockwise. Minus means anti-clockwise. Twelve kilonewton meter anti-clockwise, like this. Yeah, 12 Aman Agarwal, Prudvi Jadhav, good. Ritoban 90. So, I think all of you are getting correct answers only. So now I think you got sufficient confidence that any question given will complete in 1 minute time. That is the important thing required. All chapters together I have given you the crux of the concepts. I push it up. Okay, I think this much is enough. You are simply, you are doing, you have observed. Now, for the frame shown in figure, axial force in the member AB. 15 seconds time. 100 kilonewton. Now you see, good. Now we'll solve the problem completely. Since they didn't give you about I values, your applied 100 kilonewton is shared by the two columns equally. That means your HA $50, now if I take moments of all force about D equated to 0, you will get plus 100 into 4 minus VA into 4 is equal to 0. So VA has to be 100. This we are writing like this. Sigma MD is equal to 0. Clockwise positive, anti-clockwise negative. Plus 100 into 4 minus VA into 4. Now you have to decide whether it is compression or tension. From the pin arrow is away, that means it is tension. So force in the member AB is equal to 100 kilonewton tension. Now if you want to get the complete this one, you will get something like this. If you draw the free body diagrams, you can show the three free body diagrams like this. 100 down, that I will show here. Here it is 50. This point let us say AB 4 meters. Whatever 100 was there, that should not be kept on any free body diagram. We will keep it like this. Okay, AB, this is BC, this is CD. Right? Now if the 100 is down is there, to balance it here it should be 100 upward. 50 left side, 50 right side. Next, if I take this one, out of 150 this fellow has taken, remaining 50 will come here. So 50 plus 50, 100, this pink color one now you can remove. It should not be kept on any free body diagram. Right? 50 right side, this is 50. If you take the moment, 50 into 4, 200 clockwise, so here it should be anti-clockwise 200. Okay, now 100 upward, here 100 downward should be there. Then this is anti-clockwise, here it should be clockwise. First complete up to this, then go to the other one. VD upward, you show that VD here. $50 left. So this is upward, means here I have to show downward. Which means that force in the member CD is 100 kilonewton compression. 50 left, 50 right. 50 right, 50 left. And this should be balanced by this one. So tally it. Next, moment. 50 into this length is 4 meters. 50 into 4, 200 clockwise. So this anti-clockwise 200 should be there. Anti-clockwise, so here it should be clockwise. 100 up, 100 down. Down, this is up. This is down, this should be up. Now individually each free body diagram is completely in equilibrium. So they can ask you what is the axial force in AB, or axial force in CD, or what is the axial force in BC. BC axial force is only 50 kN compression. That also they can ask in the exam. kN. It is not necessary that they should ask axial force in AB only. If they ask BC, you will answer 50. AB means 100. If they ask BC, if at all they ask, you must draw this free body diagram, then you will know what is the axial force. So in the gate type questions, instead of asking AB, which will take only 10 seconds time, because moments about d is equal to 0, 100 into 4 minus 100 into 4 over. So that means the axial force in AB is tension. Quickly you will find 10 seconds time. So instead of asking say AB, they may ask you say BC. Then draw this free body diagram, come to this conclusion. Okay. Otherwise if they ask 1 mark question, force in the member AB. 2 marks means force in the member BC. Okay. So this is the process. This 100 kN, whatever you are showing, it should not be kept on any free body diagram, because it is shared by 2 members. Now for the continuous beam shown in figure, slope at C, we want to find what is the slope. 30 seconds time. Okay, 25 by EI, correct? How to get that? Now your moment M 100 kN is shared by 2 members. What is the distribution factor? I4 far end fix, I3 far end hinge. So first we will calculate what are the distribution factors. Joint member K sigma K distribution factors. Only one joint is required, BA, BC. Standard B, look at A. This is I by 4. Standard B, look at C. Far end is hinge. So 3 by 4, I by 3. I by 4. So 2I by 4. So 1 by 2, 1 by 2. So whatever moment 100 you have applied, both will share equally. This will take 50. Out of 100, this will take 50. Because distribution factor of clockwise, this also will take 50. Now if I take free body diagram of BC, $50 kilonewton meter if I show here, I can visualize as if it is a simply supported one, free body diagrams when I show like this. Once you sharing is over, each span can be treated independently. Okay, so ml by 3i is the formula. Slope at C, ml by 6ei. So theta C is asking, m is 50, ml by 6ei. (25 by ei). If you see the deflected profile, it looks something like this. To understand the diagram correctly, it will go something like this. This is taking 50. This is the deflection profile. This point is A, B, C. This is 4 meters and this is 3 meters. Once this share, BC member share is known to us that it is 50, I can remove this type of free body diagram I can show. So this is a known deflection profile. So when you apply moment M, at far end it must be, this formula we know, theta C is, where M is only 50, length is 3. If at all they ask you what is the slope at B, we could have answered after sharing is over, 50 into 3 by 3ei. So be careful which one they are asking, observe and accordingly answer. Okay, this is theta C. 50 by EA is at theta B. Okay. Next, for the frame shown in figure, vertical reaction at C is which method we have to use? As we have known, strain energy method we should not use because it is statically indeterminate truss. So no strain energy concept at all. Next, that means mx mdx by EI, it takes more time. More time, we can do it, but time. 2 minutes you have to complete. Strain energy, if you take it, 5 minutes it will take. Next, because of this moment, frame will sway. So moment distribution method also we should not use. If you want to use moment distribution method, you have to use non-sway analysis. Non-sway and moment distribution, sway and moment distribution you have to take it. 2 times you have to do the problem, which will take hell a lot of time. So once 2 methods are ruled out, next method is strength of materials approach. Compatibility condition. Net deflection at C is 0. So these are the conditions. Since it is statically indeterminate frame, don't use strain energy method. Don't use this one. Don't use. Next, this in 1 minute time you should be able to guess it, which one I have to select so that I will get out quickly. Don't use MDM. Why? Frame space. Since the frame space due to roller support, don't use MDM. Then what to do? Compatibility method. Use compatibility condition to find VC. What is that compatibility condition? Net deflection at C is equal to 0. Okay, now use that compatibility condition. 1 minute time. Check the answer. One minute. Okay, 42.85 correct. Rohit Patel. Now let us see how we should manage the solution. First what we do is, due to applied moment, what is the downward deflection at C we will find. So this will bend like a straight line. Since no load was there, what's the span? 4 meters. At C due to moment. Okay, so once you remove this support, BC member remains as a straight line. When you apply moment, at this BC member will not take any moment at all. In the member BC, due to your 100 kilonewton meter, moment at B in the member BC is 0. So you have to take only one member. This one. AB. BC. That's all. This is only 1 meter. Because this is free end, it has to be also, once here moment is 0, here it should be 0 only. Now for this one, what is theta B? When I apply moment, like this it will bend. We know formula for theta B. What is the length? 4 meters. ml by EI. Okay, now you fix this one. This symbolically you will fix it. Okay, so theta B into L. Vertical deflection at C. This is what you have done in strength of materials, 800 by 8 downward. Okay, next upward deflection due to VC. That also I will show this one. First symbolically fix this one. this is L cube by 3EI, but there is a reaction VC, but here theta B is 0 you have taken, but theta B is not 0. So if I take this member, VC, this length is 2 meters, this is the anti-clockwise moment, this length is 4 meters, this point is A, B. Now what is theta B? This M into L is 4 meters, ML by EI. This is theta B. Now YC2 if you want to find, YC2 theta B into L. Eight VC by EI into this length is 2 meters. This is the upward deflection. Eight VC by 3, this value is 8. If you take 3 common factor, 48 plus 8, VC into 16 by EI, VC into 8 by 3EI, VC into 8 by 3EI. $18.67. So equate both the deflections. BC will get 42.85. This, if you know why we should not use strain energy method or MDM, 50% of the problem is solved. Next deflection, this now becomes a strength of materials problem. Means compatibility condition, if you use it, quickly you will complete. So which we should not use, which we have to use, you should have an idea for such problems. So 42.85 is B is the option. This rough work I have shown, whatever way you have studied, that we can use. This is the solution. Yeah, so but already most of you got Rohit Patel, Naidu 42.85, already got that result. So we can move on to the next problem. This your calculation thing, you will manage that. I just want to tell you in this problem that what we should not do. Okay. Now we will take the advantage of symmetry in the MDM. For the frame shown in figure, moment at A is, assume A is constant for all members. Or they can ask you either moment at A or horizontal reaction at A can be completed in our stipulated 1 minute time. Now you must take the advantage of symmetry. See, this is symmetrical, this is clockwise. If this is also clockwise, say, then we cannot take the advantage of symmetry. This is your axis of symmetry. So this is clockwise, when I fold it, that clockwise becomes anti-clockwise. So that's why it is symmetrical. Okay. So if I take an imaginary frame, the imaginary frame looks like this. This is A, B, C dash. Imaginary frame. Now, whatever moment M is there at E, you will cut here, remove this, and moment at B also becomes M. This is equivalent to this one. Same clockwise you have tried it, you should not change the direction. So this is equal to this. This now we are taking the advantage of symmetry like this. Since there are no applied loads on the beam on the spans, same M I can show here. No question of changing the direction. Same moment M is applied. This is what we applied. This M is applied moment, it is not the reaction. Reaction means if it is clockwise, B member anti-clockwise will be there. B clockwise like this. So first calculate the distribution factors. For the imaginary frame. Joint member K sigma K. distribution factor becomes k by sigma k. Now joint B, two members are there, BA, BA and BC dash. BA same, I by L, in terms of length only, I by L, this is half of I by L. This we can write 2I by 2L, just to simplify the calculations. 2 plus 1, 3I by 2L. So this will become 2 by 3, this will become 1 by 3. So if I take that M and distribution factor for BA is 2 by 3, so here itself we can show that point. Out of M, this fellow will take 2M by 3. This fellow will take M by 3. Out of 2M by 3, half will be carried over. Half of 2M by 3. That means it will become M by 3. Here it will become half of this M by 6. He is asking what is the moment at A? Simply M by 3 we can write. Moment at A is M by 3. Anyone find finished? Moment at A is M by 3. Correct? Now if you want to find horizontal reaction, let us say, note, here it is, this point let us say A, B. This fellow has taken 2M by 3. This fellow has taken M by 3, half of that. 2M by 3 plus M by 3 is M, clockwise. Now anti-clockwise. These are the reactions. So horizontal reaction at A becomes M by L. This is the answer. M by 3 and M by L, Prithvi, correct? So that is the meaning of taking the advantage of symmetry. Okay, so again first from the beginning we will move on. Moment at A. Symmetry was there. Once symmetry, if symmetrical axis passes through midspan, remove BC, replace it with another span whose stiffness is half of the original stiffness. Then for this imaginary frame you will find distribution factors, you will do end moment distribution. Whatever moments you get with opposite sign you will write on the other half of the beam or frame or box, whatever it is. Okay. Okay, next one we will see. Now we see, for the frame shown in figure, horizontal reaction at A. Now we want to find, again it is symmetric axis, means frame is symmetrical, but axis of symmetry passes through the support. This is your axis of symmetry. So, you must take imaginary frame only this much. No question of taking ABC. This KBC as is we will take it. This is your imaginary frame. Okay. Now fixed end moments we know WL by 8. First one is fixed end moments. This is for the actual frame. In the earlier problem, fixed end moments we didn't calculate because there are no applied loads at all. Directly moment is applied, that we have done. Now moments are not there, load is there. You have to first find the fixed end moment, release it, then distribute it. So fixed end moments. This fixed end moments you have to calculate for the actual frame. MFBC minus WL by 8. WL by 8. Plus 60 kilonewton meter. BC, CB, NF, other is symmetrical. See here again, I6, I6. That means distribution factors are 0.5, 0.5. Now directly you can write end moment distribution. This we will do it for the imaginary frame. Joint. This is A, B and C. Distribution factors, if you have a fixed support it is 0. B and BC 0.5, 0.5 because both members are equally strong. I6, I6 was there. So this is again 0. Then fixed end moments. On the span AB no load, BC was there. It is minus 60 plus 60. Next balance. So plus 30, plus 30. Next carryover moment. plus 15, that's all. Now we can calculate final end moments. Okay, 7.5 Ayush, Raj, we got it, fine. 75 by 6. Final end moments. -15, 30, -30. These are the moments. Now you have to find the reaction. So we will draw this free body diagram. This point, let us say A, B. Length is 6 meters. 15 means clockwise. 30 also clockwise. Both of them are clockwise, so now reaction will develop anti-clockwise. (30 plus 15 by 6). So you get 7.5. I think all of you got much faster than me. Good. So this is the process. Horizontal reactionality. I think all of you have prepared completely, thoroughly, and with the same tempo, another I think now it is another 20 days you may have to maintain, or 30, February 15th, maybe 35 days like that. Then same thing maintain, rank is a must. So it's like this. So after finding the moments, draw free body diagram of AB. Both of them are positive. That means both of them should be clockwise. Then that will tell you what is the reaction at A. Okay, now next, a rigid straight bar AB of length 4 meters, weight 100 kilonewton, is resting against a smooth vertical wall and supported by a cable of length 5 meters as shown in figure. For what value of x the bar AB will be in equilibrium? This is the diagram. This cables chapter we have taken. So if you take, this is a smooth vertical wall, this is a cable, this cable length is 5 meters. Some A you take it, 5 meters. And AB, this length is 4 meters. CG will be somewhere here. This length now becomes 2 meters, 2 meters. Because this smooth vertical wall, HA will be horizontal. So on the free body diagram of AB, 3 forces are acting. If I cut this one, this will be tension in the cable. On the free body diagram of AB, 3 forces only are acting, HA, W, T. To keep three forces in equilibrium, they must meet at one point, otherwise they won't be in equilibrium. This is the CG of the bar, and here weight will act. This is a horizontal reaction. This point, let us say some O. Now HA, W, T, all the three forces are meeting at O. Now from the geometry of the structure, AB length is 4 meters. Some length L we will take it. Total length is L. Okay. AB, this point you will take say D. Since this is midpoint A, B, C, D, this point let us say E. AB midpoint is E. So when you cut vertical line, this line cuts BD into two parts. And if I cut vertically upward, move upwards, CO and OB also will be equal. Cut horizontally, if this is X, the other length also will have to be X. This also must be X from the geometry of the triangles. This is the midpoint. So this is equal to this. If I cut horizontally, this is equal to this. Cut vertically, this is equal to this. Cut horizontally, CA and AD, they must be equal. So from the free body diagram, first one is from triangle ABD. BD square is equal to, I can write L square minus X square. Call it as 1. From triangle BCD, BD square is equal to, this length we take it as A and this length is 2x. This you call it as equation 2. So now you will get from 1 and 2. So 3x square will come like this. Now in this case the value is given A is 5 meters, 5 square, this is 4 square by 3. Nine by 3. 9 by 3 means 3. So x you will get root 3 means 1.732 meters. This is the value of x at which it will be in equilibrium. So in the cables, to keep two forces in equilibrium, they have to be equal, oppositely directed and collinear. Three forces means they have to be coplanar and concurrent. They must meet at one point. From that concept, HA, W, T, they must meet at one point, that's some point O. Now you have taken triangles ABD, from triangle ABD and from triangle BCD. So from those two triangles you will get the relationship between length of the cable and this length of the bar. So you substitute, you will get that value. So this is the process. Okay, next. For the frame shown in figure, what is the horizontal reaction at A? Using portal method of analysis. 1 minute time. What is the reaction at A? In the portal method of analysis, first assumption is POC is assumed to be located at midpoint of each beam and column, like this. This is the first assumption. Second assumption, horizontal shear is assumed to be divided among all columns such that each interior column will take twice that of exterior columns. So if I take it like this, say free body diagram, here I will take 1 1. From the free body diagram above 1 1, this here itself I will show the reactions also. Above 1 1 if I take it, this is H, let us say. This will be 2H. This will be H. So from the free body diagram above 1 1, if I write sigma x is equal to 0, right side force is positive, left side force is negative. Plus 100, plus 200, hundred, 200, this is 4H. (300/4). So this is 75 kilonewton, we got it. If I take below free body diagram, free body diagram A, B, C you have taken, say this point we call it as a D. From the free body diagram of AD, for 2.5 meters it is. If above free body diagram H is acting right side, below free body diagram H will act left side. Left side if it is acting, here it should be right side. 75 kilonewton. Others we are not showing. To balance this one, like this. Maybe there are other reactions also, VD like this, but we are not interested in that, since the question is only reaction at A. So This is the answer. Okay. So, horizontal reaction at A becomes like this. These assumptions you have to remember. POC at midpoint of each beam and column. Horizontal shear is assumed to be divided among all columns such that interior column will take twice that of exterior column. If this is H, this will be 2H, this is H. So, 4H is equal to 300, H is 75. So, in other words, at A, if here it is acting left side, below free body diagram it should act right side. To balance this, HA will act left side. So this is the task in 2 minutes time. 30 seconds you can complete. Once H you get 75, tick with that, go to the next question. Okay. Interior column will take twice that of exterior column is the assumption in the portal method. Portal method of analysis, two assumptions. POC at midpoint of each beam and column. Suppose there is one more interior column, H, 2H, 2H, H, like that. Interior will take 2H, exteriors will take H. That is the assumption in the portal method of analysis. HA, WT must meet at same point, Prithvi, correct? Okay, next one. Now let us see one question. A single story building is idealized as a rigid bar supported by weightless columns. These two columns you assume that they are weightless as shown in figure. For the dynamic response using a jock, at this point we have kept a jock, means a force applying device. A displacement of 5 mm of the girder was observed for a force of 10 kilonewton. On this system, I hold it applied 10 kilonewton. So that it moved by a distance of 5 mm. So for 10 kilonewton 5 mm means for 1 mm what is the force? That becomes the stiffness of the system. So we can write stiffness of the system. W by delta, five mm. Okay, so stiffness you will find W by delta, and the time period of displacement when I pull it by 5 mm by a force of 10 kilonewton, it moved by 5 mm and lift it, and time period as given for each cycle 1.5 seconds. So time is known, stiffness is known. What is the natural circular frequency of the system? Neglecting the effect of damping. That means actually damping will be there. Don't worry about the damping factor, don't worry. What is the frequency? Circular frequency. So time period, W by delta means 5 mm means what you can write? 5 into 10 to the power of minus 3 meters. So stiffness becomes 2 into 10 to the power of 6. Stiffness should always be measured in terms of newtons and meters. And time period. Time period also is given omega n. Natural circular frequency. Circular frequency means what? 2 pi by k. Two pi by t. So stiffness of the system we don't require at all. I think you will get 4.19 radians per second. It is like only story, big story they give you, but whatever it is, your engineering mechanics, whatever you have studied, natural circular frequency means 2 pi by t. Time period is equal to this basic formula we have given. So like this, in the gate they don't ask you beyond this one. If they ask you what is the stiffness of the system, how much load you have applied, how much it displaced, load by load by displacement will give you stiffness of the system. So that's all. 4.19 is the answer. radians per second. But if you have to find use in the stiffness, this is the formula you have to take it. Yes, correct. So I have sufficiently given the overall brief overview of the likelihood questions in the gate. Important chapters are like this: analysis of trusses, means where you can find method of joints, method of sections, how to find the forces you have seen, deflections of the trusses or relative displacements, then the influence line diagrams, simple cases, or deflections of the frames, or in moment distribution method, whatever I have given, or in the cables, some chapter like this. Then in case dynamics they ask you circular frequencies, either one question, otherwise no question at all from the dynamics part of it. Okay, all the best my dearest. I wish you all the best for your exam. Don't strain yourselves too much as far as the structures and steel is concerned. No question takes more than 45 seconds to 1 minute time, as we have seen in this one. This is how the questions will come, either this type of questions or no question at all. Okay, so without straining yourselves too much, revise the class notes thoroughly and go to the exam. All the best.